All right, we're continuing to prove that triangles are congruent to one another. We're going to learn a couple of theorems, and we're going to these particular theorems, the ones in this lesson and in the next lesson, we're going to kind of present in almost a more generic way. We're gonna you'll see what I mean here in just a second. It's gonna be less about writing things down and writing out words and more of kind of understanding what's going on. Let me show you what I mean. So the two theorems, the two ways that you can prove triangles congruent in this lesson, we'll learn two more in the next one, are side, 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 and side angle side. So the S's here helps to have the right tool. So the S's equal side, and the A's here equal angles, right? So that's what we're talking about. So, and what we're saying here, and what the side, side, side theorem says, is that if all three sides of triangles are congruent, then the triangles are in fact congruent. So it's pretty straightforward. So now, instead of having to know all three sides and all three angles, we can, if we just know these three things, then these two triangles are congruent, because we can't make it bigger or smaller because all the sides are equal and all that kind of stuff. We could explain why, but it's the easiest thing to do with these guys is just say, okay, if all three sides are congruent, then it's congruent. Now you notice there's more writing over on the side angle side of this screen. And the reason for that is because the order and positioning matters. And I've kind of got a this, not this idea going on here. So the order here matters. So it's got to be a side with an angle in between and then another side. So side and then the angle and then the side. So it's this side angle side, side angle side, not this. There is no SSA. And I didn't write this way. I wrote it this way instead of angle side side, because that would be no good. And that might help you. And I point that out mostly because that might help some of your brains remember that this is not a thing. Side, side angle is not a proof of congruence. So it's got to be, for side angle side, it's got to be the side and then the angle in between and then another side. So we're actually going to do two different proof examples in this lesson. So let's jump into them. Neither one of them are going to be particularly long. So we are given this picture, first of all, and we're given these things. So let's start labeling the given and writing it out. So we're given that triangle QRS, so the triangle, this big triangle here, is isosceles with QR congruent to SR. So I'm going to go ahead and label that. So QR is congruent to SR, right? And RT bisects QS at point T. Now, that's gonna tell us this, right? But it doesn't tell us that yet. All it says is that these two bisect. So let's go ahead and get our given stuck in the proof. That's always the first line of the proof. So given, oops, oh no, that is the letter. I don't know. Something in my brain happened. So we're given that triangle QRS is isosceles. And we're given that segment QR is congruent to segment SR. Okay. And we're given that RT bisects QS at point T. All right, so that's all our given. So we need either side angle side or side side side, because that's the only two that we know. So I just kind of gave away a piece of it. So we need to look at, it's important. I've said this before, and it won't be the last time I say it, because it's the sooner we kind of get this idea in our head, the better. So we need to make sure we are using the given to do this proof. Now, the first bit of the given is easy, right? So we've got sides here. So we could try to go for these angles here maybe, or we could go for all the sides. That's probably where we're going to head in this one. So that first bit is easy, how it gets used. what about the bisecting? Well, what does bisect mean? Bisect means it cuts it in half, which means that one side is congruent to the other side. And so we can just say that now. So we can say that QT is congruent to ST because, so segment QT is congruent to segment ST. Because, and why can we say that? We can say it because bisector, because the definition of bisector, right? Okay, so that's how we can say that. So now we've got two sides. So if we get the angle in between them, we don't really know anything about that. We're probably not going to go for side angle side. Can we get the third side? Well, it's a shared piece. So it's shared between this triangle and that triangle. That's what we're trying to prove. I didn't say that at first. It's written on the screen. I forgot to say it. But we're trying to prove that this triangle is congruent to that triangle. They've got a shared side. So since they have a shared side, what can we do there? We can say that this segment is congruent to itself because of the reflexive property, right? So the third step is going to be that segment TR is congruent to segment TR. The reason why they're in the same order is because these triangles, instead of being, they're just, one is reflected over the other. They're not like this. Since they're in the same order, I wouldn't, on one of my tests or something, I wouldn't count off for that probably, but that's why it's there. It's TR is congruent to TR instead of RT or whatever. It's because they're not twisted. That's why. That's the difference there from some of our other proofs. The reason we can say that again is because they're shared. It's the reflexive property. Flexive. Right? So now all the sides are congruent. So we can now be done. We can, step 4, say what we're trying to prove. This guy right here. We can say that triangle QRT is congruent to triangle SRT. Easy as that. And we can say it because of side, Blapo. Done. Finite. That's all there is to it. These proofs, I've been telling you that you're going to like these proofs better, and I hope you can see why that's true. It's because we have clear goals, and they tend to be a lot easier, so a lot more straightforward. So let's do one more. You can probably guess what the last line is going to be because of what we use in this slide. All right, let's put our givens on here. So we've got this picture and we've got these statements. So WX, so that's this guy, is congruent to YZ. So they are congruent. We're also told that they are parallel. So we're going to label them as being parallel. Ooh, that might mean that we might use a theorem from the last chapter. It's all coming together. So since they're parallel, we've got like 1, 2, 3 transversals. So we could almost certainly do something with that. But let's get our given down first. So our first justification is always given, and our first statement is always the given. So W, X, Y, and Z. No, just kidding. Well, it is. WX is congruent to Y, and no, just kidding. Z, I don't know. It wasn't a very funny joke. It's okay. We'll all get over it together. W, we're also given that WX is parallel to ZY. Great. So, what else can we do? Well, we've got a shared thing. We could probably do reflexive property. Whoops. That might be something you might notice. So let's, I'm going to kind of just go with this. You could do these things in a lot of different ways. We need to either get all of the sides congruent to one another or side angle side, right? Those are our ways to prove it. So let's go ahead, because we can see the reflexive property. Let's go ahead and say that X, and this is a good example of what I was talking about a minute ago. This time the triangles are twisted, and so we're going to put that in a different order. We're going to say that XZ is congruent to ZX, right? Because of the reflexive property. Reflexive property. Okay. All right, so we got that labeled. So could we get the angle in between them? So that's this angle right here and that angle right there. Can we say that those are congruent? We can. All right, and the way we can do that is, see, we've got this, these two are parallel, right? This one and this one. So we've got this transversal that cuts through them. Well, this one right here and that one right there, what are they? They are alternate, so opposite sides, interior. Alternate interior angles are what? Remembering your remembery, they're congruent. So that's great. We can say that this angle is congruent to that angle. So step 3, angle. Now, this is important, and this I would count off for. Or right here, you could not just say angle X. Why can't you just say angle X? We can't say that because there's not just one angle there. There are two. So we have to label that with 3 points instead. So angle WXZ is congruent to angle YZX. YZX. Because, like I just said, alternate interior angles. So don't forget, it all, one thing builds on top of another. We can't forget, we've used, and we've seen this already, but you can't forget the old theorems, because the old theorems are going to come back into play again. So now we have side, angle, side. So we can say what we're trying to prove. Step 4, triangle. You have to hit shift and not caps lock. I can do this. There we go. Triangle WXZ is congruent to triangle YZX, because side, angle, side congruence. That's it for this lesson. We've got a couple new theorems, couple new proofs. We even did 2 proofs, and this video is still under 20 minutes long. That hopefully will give you some encouragement to the fact that these proofs typically, not always, obviously, there are exceptions to almost any rule, but they are typically easier and more straightforward. I hope you have gotten good stuff from this. If you're one of my students, I'll see you in class. If you're not, thanks for joining us. We'll see you in the next one. Bye-bye.